Welcome, everyone. Today, we're going to pull back the curtain on something really cool: how the business rules you write in plain language are actually understood by a decision engine. We're going on a journey from simple business logic all the way down to the engine code itself. So let's kick things off with a big question. You write a rule that's super easy for anyone in the business to read, right? But what's the magic behind the scenes? How does that get translated into something a high-performance engine can chew through in milliseconds? To answer that, here's our game plan. We'll start with that translation, going from the business action language, or BAL, to the engine's own language, the advanced rule language, or ARL. Then, we'll break down what an ARL rule actually looks like, see how it handles data, explore some of its most powerful tools called aggregates, and finally, see how it stacks up against Java. Okay, let's dive right into that first part and see this translation in action. This is really where the human-readable stuff becomes machine executable. And here it is, a side-by-side look. On the left, a nice, simple BAL rule. On the right, what it becomes an ARL. Now, ARL is the engine's native tongue. It's read-only, and it looks a lot like Java 7. But notice the big difference right away. If in BAL becomes when in ARL. This isn't just a word swap. It signals a totally different way of thinking. The engine isn't just checking a condition, it's actively pattern matching. It's searching for data that fits the description in that when block. And that is key to how a rule engine works so darn fast. So let's break down this ARL code to really understand its structure. I know it might look a little intimidating at first, but trust me, each little piece has a very specific and important job to do. Okay, so every ARL rule has a few key parts. It always kicks off with the rule keyword. And you'll see these back quotes, which are pretty clever. They let you have spaces in your name, something you just can't do in standard Java. The when block is where all our conditions live. A binding just creates a new variable for us to use inside the rule. And evaluate is how we test a specific condition. And finally, that weird-looking dot-looking engine data.this. That's just the special way ARL points directly to our data, so there's absolutely no confusion for the engine. Now, here's where things get really practical. It's one thing to look at a single borrower, but what happens when you have a whole list of them? ANRL has a very specific way of handling one versus many, and it's crucial to understand. And this slide just nails it. The difference comes down to one little keyword. When you're dealing with a single object, like the borrower, ARL uses the keyword from. But the second you need to loop through a whole list, like a bunch of co-borrowers, that keyword flips to in. It's a small change, but it tells the engine a completely different story. Look at one thing, or look at everything in this group. All right, let's get into what I think are the real power tools of ARL, aggregates. If you're dealing with lists or collections of data, these are going to be your best friends for summarizing and analyzing all of it. The best way to think about aggregates is to think about databases. You know, functions like count or sum. It's the exact same idea. They let you perform some kind of check or calculation on a whole group of things at once and boil it all down to a single answer. We're going to look at three of the big ones: collect, count, and exists. First up is collect. This is your go-to when you need to filter a big list down to a smaller one. It's perfect for creating a new list on the fly, like saying, hey, go find me all the risky borrowers from this giant pile of applications. You can see it right here. The BAL on the left is pretty clear about what it wants. The ARL on the right makes it happen with a collect aggregate. It's basically telling the engine, I want a new list called risky borrowers, and I want you to fill it by collecting every single borrower you can find whose yearly income is under 1,000. Next, we've got count. And yeah, this one does exactly what it says on the tin. It just counts how many things in your collection match what you're looking for. It doesn't care who they are, just how many of them there are. So in this example, the BAL is asking, are there exactly 8 borrowers who meet this income level? The ARL uses the count aggregate to find out. It gets a number, the total count of everyone who matches, and then it just checks if that number is equal to 8. It's a very direct way to answer the question, how many? And finally, there's exists. Now, this one is all about efficiency. It doesn't need to count everybody. It doesn't need to build a new list. It just needs to find one single match. The very second it finds one, it's done. And I love this translation. It's so direct. This simple, elegant phrase in BAL, there is at least one borrower, translates pretty much one-to-one into an exists clause in ARL. This keeps the logic crystal clear and super efficient. It's just a simple yes or no question for the engine. Okay, for all of you out there with a Java background, this next part is for you. Let's put ARL side by side with Java 7 and really highlight the key differences that make ARL so specialized for running rules.
So while ARL and Java 7 are definitely related, they are not twins. ARL has its own unique keywords like rule and aggregate that you won't find in Java. It's got those awesome backquotes for identifiers with spaces. For typecasting, it uses the as operator. And a really handy one, its switch statements don't need a break after every case. All these little things are designed specifically for the world of rule processing.
So, why does any of this matter? What's the big takeaway? It's this. By learning to read ARL, you're basically learning to speak the engine's language. You get a direct, unfiltered look at how your business logic is actually being interpreted. And that deeper understanding is a superpower for writing clearer, more efficient, and way more predictable business rules. And that leads us to one last question to think about. Now that you can peek under the hood, now that you can read the engine's own language, what new possibilities does that open up? How might you think about designing, writing, and even debugging your business rules differently from now on?